Hello everyone, thank you in advance to all participants that watching my presentation. I am Nuzul Fatma Septiana from Universitas Pertamina, Jakarta, Indonesia. Here is my research entitled Safety Stock Analysis of Ship Fuel in Shipping Company. Policy in 2019 of a shipping company implementing a system by refueling ships for each voyage. Voyage means a ship that has carried cargo loading to discharge the entire cargo. This policy has positive and negative effect. The company will certainly focus on the negative effect. Steps taken by company is to add safety stock. This is the stock that is prepared to meet the fuel needs of the ship during the trip. The determination of safety stock will be carried out based on standardized data resulting from the use of the method applied by the company. This research focuses on the safety stock method, where the parameters in determining the safety stock are demand and lead time. Before that, I will determine what size ship will be examined. The company certainly has ships of different types and sizes. This calculation uses a formula to determine the number of samples according to Walpole in his book entitled Probability and Statistics for Engineers and Scientists, with the information that has been mentioned. Determination of safety stock has discussed by Torres in his research entitled Safety Stock Determination Based on Parametric Lead Time and Demand, with the information that have been mentioned as well. Okay, next, in the case study, the regulations set forth in the policy are to refuel each voyage using safety stock 40% of the supply. The effect that is too much safety stock will cause sediment, or safety stock is too little, so that the ship lacks fuel. This picture is an illustration of the sediment that arises. The bad effect that will occur is that the pipe will absorb sediment and will cause engine damage in the long run. Therefore, the purpose of this study is, first, by determining the maximum volume of safety stock. The second, determine the variable that affect the calculation. And the third, safety stock amount. Then the result and the discussion will be based on the flow. Sample calculation will be carried out in 4 steps, which will be explained in the next slide, and SSOB calculation with 3 calculation components, then closed by the analysis and the result. This is sample calculation with the p-value and confidence level determined by the company. A total sample of 2 vessels is obtained. As previously explained, the company has many types and sizes of vessels. The determination of the object of this study was filtered using the following 4 stages. The first step is to find a ship that has a sister ship or ships with similar specification. And then second, make sure the ship has a good trip record, small frequency delays, or etc. The third, ensuring the required vessel data is still available. Then finally, ensure that the ship has the most travel history. After the selection, we get a couple of ships. That is the ship to be examined, and then the sister ship. SSOB calculation, which is a calculation by processing some data in the form of ship speed and the amount of fuel consumed every day in sailing condition. This calculation will produce data on fuel consumption and sailing time if the ship is sailing in accordance with the contract condition. This data is used for the calculation of safety stock. The variable used already has a fixed value based on the ship's standard data. After standardizing data, A travel recap is obtained as follows. Most trips are trips that are 286 nautical miles, 320 nautical miles, and 538 nautical miles. If calculation using uneven data will produce inaccurate calculation, then I will make dummy data for safety stock calculation. The data load is database on the 3 distance history that is often carried out by the ship. Then this is the method divides the data into 2 calculation categories. The first calculation uses heterogeneous condition. This calculation is based on ships sailing randomly at these 3 distances, with a percentage of the amount of data as follows. This percentage is based on the number of the frequencies that have been made before. Whereas, for homogeneous condition, it is assumed by the ship only sails on one type of trip, or we can call it distance. Safety stock calculation take into uncertain demand and uncertain lead time. Then this is the calculation produce the safety stock as follows. The result will be more consistent if the calculations are homogeneous. Results like this are caused by the variance of each variable. The higher the variance, the greater that of safety stock or safety amount. Then the following is a plot of the calculation result. I'm trying to test with the 2 approaches that best fit the graph. The linear approach is shown by the red line and the exponential approach is shown by green line. From the 2 approaches, it can be seen that the exponential approach is still within the predetermined error limits. The 2 plot approach are shown in the green table. Exponential approach have better results with fewer safety stock as well. The average increase in the number of safety stock from exponential estimates is 0.056% of each nautical miles. Okay, based on previous calculation obtained with safety stock volume for 3 highest frequency distance, and the second, the variable used are fuel consumption as demand and sailing time as lead time. The input data is the ideal data. Third, the safety stock percentage of this distance using an exponential approach. This conclusion is the end of my presentation. Thank you for your attention. Stay healthy and have a nice day. Thank you.